Okay, I am extremely excited about today's topic. Today we're going to cover at least two sets of Nobel Prizes. But no small feat. Very excited about this. Okay, so I want to start with maybe the easier part. And again, I'd like to do this hands-on. So what I've done here is prepared a data set. And I've sent this over the Slack channel. Taylor, are you there by any chance in the Slack channel? Oh, share the screen. Of course I can share the screen. I thought I was already sharing the screen, but thank you. Let's see. Do folks have access to the Slack channel and the files I just shared? Folks online also? Perfect. All right. So I shared a small artificial data set together with an R markdown file that lets you recreate this plot. It looks like this. This is an extension to this interrupted time series analysis we started talking about, where you have some group that experienced an actual intervention, and you have a control group that did not. And the data are aligned on the same time points between the two. That make sense? We talked last time about how this is a much stronger design insofar as causal inference is concerned. Because why?
Other possible explanations, the controls for other possible explanations for the behavior that you're observing.
And what's the billion-dollar idea for inference?
And you can basically subtract out all the stuff that you are not sure if you people accounted for with the more basic approach by just looking at the control rate.
That's the billion-dollar idea. That instead of measuring the just the difference between the after period and the before period in the group that was treated, that experienced the intervention, we also measure the difference between treated and control. And this way eliminates all of the confounding factors that would have affected both groups. This by itself is the first Nobel Prize idea. Something called difference in differences is the technical term for something like this, where you take the difference of these differences between treated and control. And folks have gotten a Nobel Prize for this, I don't know, in like the year 2000 or something like this. Okay, so really super powerful idea. This is Nobel Prize #1 for today. So what I'd like you to do is model this jointly, similarly to how you've modeled this interrupted time series before. Model this jointly to estimate, let's say, the causal effect of this intervention. That makes sense? With the data that I provided. And you can obviously use the R script as a starting point. Say it again. Oh, let me get it. So I'd like to see a regression that models this data. Be very similar to stuff we've done in class last time. Hopefully this won't be too difficult. Bless you.